I'm Peter Rosberg. I work for a place, a little phone company, a little IFC here in the country, but I'm from Sweden, and Sweden is a little country. Oops. For the people of you who doesn't know, for the ones of you who doesn't know where Sweden is, here's a brief travel description. You go north, you hit Canada, you continue, you hit water, you turn right. And then you're in the middle, you're in the south part of Sweden. No, we don't have ice beers, but polar beers, I think they're called. Now, Sweden is about the size of California in area, but it only has 9 million people. And so the government is like kind of local. You can walk down and hit the ministers over the head. And we were looking into what should we do for infrastructure for a country. And I know there are some concepts in here you can't do in the US, but for a little country where the polar bears are taking up some of the space, it may be possible. It addresses very interesting scalability problems that I don't think we have thought of yet, that's going to hit us anyway. So I wanted to share with you some of the things we have been looking at. So the background to this is, we use Sweden as a company. This is Sweden Inc. And what should we do for infrastructure to be profitable? Historically, government has been providing railroads and roads and water and stuff, right? And maybe we should make infrastructure for the future being something. Everybody here knows how bad it becomes when the government tries to deal with technical things. They usually fuck up totally. Yeah. So we want to keep the government out of that, and because the government can't find employees that are smart enough to tell the difference between a toaster and a router. So there's something called the IT Commission in Sweden, which is part of the Ministry of Trade and Industry. And they are looking at what to do. Okay, this group has the chairman, and the chairman is the Minister of Industry. And this guy became famous because he uses the government's credit card to go to Kit Kat Club kind of thing a couple of years ago. So he knows what the major application for the network is going to be. So if you look at Sweden, it's 450 kilometers wide. Okay, it's 1.6 thousand kilometers long. It's about 1,000 miles long, and 9 million people. So that gives you 12.5 person per square kilometer. And the only place that is less dense populated is Sahara, and some parts of northern Canada. Now, the IT Commission has a lot of people sitting there doing not very much. So you have the chairman on the top. I'm trying to make a drawing here, and the chairman is the minister, right? And then there are people there. And then there are study groups, and there are 3 study groups that I know about. One that is doing absolutely nothing. They talk about e-trade. One is talking about legal stuff, but what does the lawmakers need to do in order to make this information stuff work? And the other one, the last one, is the one that worries about infrastructure. So the study group for infrastructure is trying to figure out what to tell the government what to do next. And we agreed on that we want to have a broadband infrastructure, and broadband is the best word, okay? Maybe broadband translates to dedicated access to everybody's home that actually works, okay? At an acceptable cost, and we should be able to reach everybody. In order to make this work, you have to identify the issues and what they need to go, and we have to make proposals, okay? So the vision was within 5 years, and if you think 5 years is a long time, you will figure out from the rest of my talk there's a lot of digging to be done, and there are not enough digging machines, so 5 years is not that long time. Why do I say 5 megabits? Well, I think that 5 megabit is the bottom line useful connectivity you can have, because if you want to stay at home, you want to do your work, which doesn't take that much bandwidth, but then you want to watch the gossips in the cafeteria, you want to do some games, and you want to surf the net, and you maybe want to watch TV. So 5 megabit is kind of where it starts to become useful. My idea was to build a network that can go both directions. So this is 5 megabits to and from the users, because one key thing here is to be able to make people capable of doing things from their house that they can make business on, or that we can make business on and sell to other people in Germany. Other Europeans. If you build something in infrastructure, so the key is like, either I stay at home and work using my electronic stuff, or I go to work. And go to work is we have public transportation. Those are called buses and subway stuff. So here they have a tram. I think it's a toy for politicos. You can go from here to Cisco and back again. So in Sweden, you are comparing your cost of transportation with the cost of the bus pass, and it's about $75 a month. So this 5 megabit service, using it for basic stuff, not doing anything fancy, the goals are extra, is $75 a month. And some people you may say, oh, this is not possible. It actually is, but you can't feed a PPT any longer. Okay, you want to have a competition, and why do you want to have competition? Well, we want to have the latest and greatest technology available. Okay, so we're narrowing down here. So it turns out that you need fiber, okay, and then people come to me and say, hey, how about radio, satellites? And you have to explain to people, you shoot up a satellite, it has a fixed bandwidth, it comes down after 5 years. You explain to people, radio, look, have you seen the tower on the building over there? Do you know how it gets there? Wire? So after a long talk, you explain to them, look, if you put fiber in the ground or conduits in the ground, it has a lifetime of at least maybe 50 years, and it becomes better every year, okay? Because the fiber is not really the limiting factor. What you put at the end of it is a limiting factor, and that's pretty easy to replace. Fiber to the house turned out to be very useless because at home we put the 12008 on top of the fiber patch cord, and after a day and a half the sheet metal had cut it. So it stopped working. So what you want to do is probably get Cat5 cable, which is something you can deal with in a household, and you can put the cheap hub on there as the delivery method. And within 100 meters, it's like the Ethernet specification is 160 meters, right? This is like as far as you can go with Ethernet because if you're running half duplex. So we want to get 5 megabits over a Cat5 cable to everybody, and that means that you have to get fiber within 100 meters from everybody's place where they live. Okay, and there are places where so little people live that there's no commercial company or carrier is going to even think about running fiber there, so it's a state problem. The bottom line is the important one. Communications architecture, IP. Here people ask, IPv6. I say, oh. Okay. There's enough addresses in IPv4 that if you renumbered everything and you get let's see here, you get 1/4 of the address space to China, 1/4 to India, 1/4 to North America, and 1/4 to Europe. There's one address per household. Okay. In order to build such a network, you have to allow the operators to figure out how to get the bits to the house. You can't make a decision, if you're the government, you can't make a decision on how to build a network because then you already limit their ways of competing or their ways of building stuff. So you have to say, we have to be able to get fiber within 100 meters for every building, and you have to be able to get that fiber there in such a way that they can build stars and rings, whatever they want. Okay? It turns out that 5 megabits to 3.5 million households is a hell of a lot of megabits. And if you try to build a network we used to build networks, it won't fit. So we have to do something more intelligent. And there is also a defense issue here. If you build an infrastructure, you really don't want it to be easy to take out. If you have like 4 backbone paths or 4 major railroads in the US that carry most of the fiber, it's very simple. If some stupid people, one proposal I heard was to put them up in the power lines. Gone. Takes an old lady. So the idea is have the state put the fiber, okay? And I know some people here are making a living out of putting fiber. Sorry, you can put them in for the government and they can give you the money. Then you want to charge the ISP a fixed cost per house. So the cost per house is going to be the same if you're in the middle of the city where there's about 1 million people living, or you're in the middle of nowhere. And remember, it's optics. It's not much hard to go between 2 buildings in the city versus go 50 kilometers out in the forest. It doesn't really matter from what kind of stuff you put in. And the bottom line, I heard from the political comments already, owned by the state. Like, but the state, it's okay if they own roads, but I hate toll roads. So, so you have to put in enough fiber so you can have multiple operators to be present in any geographical segment. That means that we have to put in enough fiber. So we were looking and playing around and said, okay, we should make it possible to have 40 operators in the city, and it's a hell of a lot, 40 operators per building. Then you have to dig this fiber in such a way that you get 2 paths, because if something breaks on a Friday, it has to be able to be self-healing and work until Monday when they can get people out, because the service staff, remember, it's like minus 10 degrees Celsius, cold, and they have nothing to do and it's dark. so you get lots of alcohol. So if you sit down and say, okay, let's figure out what we do. So what do we need? What's the layers of infrastructure? Well, physical layers, fiber cables and routers. And I mean, I just lumped all this technology stuff together. We need to have the logical layer, traffic exchanges. How do we get traffic from those two providers? We have to get DNS time. We have to get security working, because now this is for life and for real. We have to get all the legislation working, and we have to find enough people or create enough people with enough clue to keep it running. The last line is very tricky. Now, so to get closer. So to the operator, the government should give dark fiber, nothing on it, okay, not even WDM. And burglar alarm loop is basically that the government or the city or whoever provides the fiber has to be able to tell if it broke, somebody cut it, so they can go ahead and fix it without having the operators to tell them. You have to build the fiber plant where you can do both rings and stars. You have to put in enough fiber so you can have 40 operators in the city, 15 in the suburban, and 10 operators in the middle of nowhere. If you play around with numbers, you find out that you have to build a national grid with about 350 pairs, and they are spaced 50 kilometers or something apart. Here's the trick. So we give the operator the fiber. The government gives the operator the fiber. Okay, what do we ask for in return? Well, he has to deliver a plug at the user that gives him IPv4 unicast and multicast, and IPv6 whenever it works. Okay, and it has to be 5 megabits from anywhere to anywhere within Sweden. And at least 70% of the 5 megabits should be capable of multicast, because they're going to watch TV or something. And TV is one of those things where, TV and radio is one of those things where one to many is where I think we can make multicast work. Many to many is slightly still something tricky. Then, if you say that minimal delay between subscribers in the same city should be 20 milliseconds, you may wonder, why does he put it there? Well, I want to tell the different operators that they have to figure out how to interconnect, because it's not going to be the government's problem. I just say it has to be less than 20 milliseconds. Go figure it out. Then you have a problem. You have to buy capacity to other countries. And I don't want to have to design a special system where we have a NAT in front of the country or something, or a cache. So you have to figure out, how do we make this work with the rest of the internet? And one way of saying is that for every household, at least 300 bits per second should be global capacity. That rounds up to about 1.2 gigabit, which we already have today, so it's a no-brainer. But that way you don't need to do any special hack. The DMARC to the user should be 10 or 100 megabit Ethernet. And then I say, well, look, the biggest unit that should go away if something breaks is 42 households or 42 customers. And then you say, well, you have to make it restore pretty fast. And then the stats contour is, if I try to translate it to English or to American, I would say GSA. They actually wrote a specification on what an internet service should be for the government agencies. That actually makes some sense, so why not just use it? Why? Well, if Sweden did this today, anybody who was an equipment manufacturer, anybody who was an operator could just step in and say, hey, we also want to play. And the state only needs to make sure that everybody has a phone, everybody has the same connectivity regardless of where they live, right? And today they are caring for that everybody has a phone where they can call 911, or in Sweden is 112. Now, so why don't I want the state to build a phone company? Why don't I want a city-run operator? They're really lousy, okay? So, but they're really pretty good at running digging machines. So how about doing this? The horizontal things are people digging. Those are cities and government agencies. They're digging, they're putting in the dark fiber. The vertical bars represents the operators, and in Sweden everything is called tele something, so there are tele 20 through 70 here, okay? So those are operators. So basically the service providers are nationwide or worldwide, and the fiber provider are local. So if you try to tell the government guys, you say, hey, look, you have cities, and you have the cities that run the fiber to the next city, okay? It's pretty simple. Then you try to explain to them what they do inside the city. Most cities in Sweden are very small, so you have to have two sites where they can have all the fiber patch things and provide co-location space. Those are the big blue pluses in the middle. And then you go out all the way to A. A is the end users, right? Those are houses. And the green one that goes like this are the nationwide grid. Then you get to the building. I don't think we can use the copper cable already there. It's usually 20 years old or 50 years old. It's paper isolated copper. And 20 years ago, the nitrogen, they had to pressurize the cable run out, so it got water in there, so it's pretty useless. So you probably have to do new cabling. And if you do new cabling, why don't you just do Cat5 cabling from each apartment to a shared space somewhere in the building, so you get new wiring from up here down to a patch panel. Okay. The router things here, which are named operator 1, 2, 3, 4, represents the different operators. And they have a free choice of what technology. I put a box that looks like a router there, but they may put a bridge or switch or whatever they want. And then this is the interface to the state fiber. And there are some geeks living in this building, right? Those are the ones that actually have 2 plugs, 2 operators. So the demarc to the user I expect to be just Ethernet, or Ethernet that goes to a set-top box. It's pretty simple to take one of those boxes that receive the digital stream from the satellites, take the radio out, and put something that can receive multicast packets and to decode the MPEG-2 stuff. So I see a new industry of people producing boxes that do things. You can walk over to Fry's and buy this 4-line PBX with IP functionality. If I were to build this network, okay, so in order to say what I already said, I had to figure out, okay, can I build this network? And I said, well, maybe. Let's see what I would do. So I would do like this. I would build a ring, use some kind of ring technology. Our friends at Cisco have done something called DPT that does almost what I want. So you put 2 core nodes and you put a ring, and this is the 2 sides of the street where you have the subscribers sitting, right? And for the next street over, you make another ring. So what you do is I would build like this. From the city fiber center to the other city fiber center, I would build a ring like this. Then I would put boxes out here that has lots of intelligence, very intelligent routers, because I don't really want anything in the middle of the network, because when I add customers, I only want to see more packets. I don't want to have more intelligence in the center of the network. And then I started to scratch my head and say, many megabits. Another thing is that when you demarc today, we end up putting NAT boxes and all sorts of stuff in front of the users, and sometimes it's not very useful. Like I see games that actually takes the IP address and stick it in the same way FTP does. Sometimes you want to have a VPN, like if H1 is farther in the house, working at home, he wants to be part of the company VPN. H2 is the woman in the house, she's learning French, and H3 is the kids playing games. We have different requirements, so the box has to be pretty intelligent in order to figure out what MAC address to do NAT for, what MAC address to encapsulate and send it over to the VPN of father's company. So I think we need to we are going to a situation where the edge box has to be much more intelligent, and then you say it's too expensive, but hey, figure out how many of those boxes there will be in the world. If you're trying to build a backbone, the way we used to build backbone like a tree, you have like access and core, it's not going to work. You're going to create a hotspot in a network where you're going to push technology beyond its limits. So you have to avoid pushing technology beyond its limits. If you look at some of these people trying to build high-end routers, they're always playing graph theory. They're trying to put funky topologies between nodes in their box. How about just make the whole thing a big router as a cube? So that I'm assuming that we're building a cube out of the entire country. And that way you get a fair amount of paths between any site, say anywhere else, and you get so much redundancy that if somebody wants to take the network out, they have to work really hard. This is what I've seen people doing in this kind of application. Like they put an Ethernet switch or a couple of Ethernet switches, they put the web server that they call the community web page, and then it's a NAT box, and then they have ADSL going out for 50 or 100 apartments. No fun. Now, why am I bringing this to NANOG? Well, if you take 3.5 million 5 megabits ports and you say this is worst case scenario, like they all talk to each other. It's 17 terabits per second. Now, this is assuming that half of the people are waving to the other half of the people that are watching, right? Because I have no content provider. If I end up having to have a content provider to feed all of these guys, I need another 17 terabit of egress going into the network, or ingress going into the network from whatever. If I want to have 3 operators, which is a very low number, my single exchange node point needs to handle 5.6 terabit per second on the link to the ISP here. If I try to spread it out, I need 2,344 OC48s between those three operators. And if I want to double the capacity every 18 months, in the internet, in the core backbone, we usually played around with 9 months doubling, but here we are dependent on the user getting a faster PC or something faster, so I don't think it's going to go at that speed because we are taking the effect of doubling by, the internet core today is taking all the new users into account. Every user doesn't go faster, but here the users has to go faster. If you double every 18 months, it's OC48 to everybody in 14 years. Okay? And then people say, hey, I can build OC48 to my house today with technology I can buy, and 14 years is a hell of a long time. How many of you were playing with internet stuff 14 years ago? Not that very many, right? So I don't think it's an utopia, and I think it could be done, but we are going to run into very, very many new problems to solve. Like if my cube is actually having multiple providers, how do we interconnect them together? Another thing I wanted to explain was that people say, hey, we have voice. And you see all those old telcos, they're living up, they're taxing you for talking into the phone. If we did something like this, everybody got IP to their house, right? The voice gateway here is just their phone. I just show the phone here, but if this is the phone, this is the box from Fry's that has an IP plug, a POTS line, and 3 POTS lines to the phones inside the house. You pick up the phone and you dial a number. If we do a DNS lookup on the phone number, we can try to see, can we talk to the box at the other end? Yes, they're on the internet, fine. There won't be any minutes seen by any gateway anywhere except for the 2 endpoints. And if it doesn't work, just pick up the phone and dial. Over time, traffic will move from the PSTN to the public internet as the quality and availability goes up. Here are questions that I put down, and I would like you guys to think about it. There are some new issues here, and I think, if I listen to the discussion we had earlier here, the same problem is going to arise everywhere, so we better start working on it. How do you do interconnects between ISPs at those traffic layers and at those many exchange points? How do you even manage it? Okay, I'm looking at it from a Sweden perspective, but it can be any city. Any city in the US which had local providers. How do I get connectivity outside, and how do I do that? How do I market it? Do I sell it as a separate product? Do I have long-distance service provider selection? How do we actually do addressing? I know it should be network-based addressing, but here geographical sometimes makes some sense. How do I do service provider selection? How do we troubleshoot this? We're going to have 3.5 million ports out there where Joe Banana can plug his phone in instead of his computer, and he calls in and says, it doesn't work. And then he goes, are you an IPv4 or IPv6, sir? Does the routing system we have today deal with such a situation? Can we actually do this? Does the routing system we have today, is it capable of doing all of this? Well, I don't think so. Well, that's about it. I would like to encourage people to come up at NANOG with presentations on how to solve some of those problems, or send me a mail and tell me I'm nuts. Conclusions: more fiber in the ground, more competition, IP as a communications architecture, unlimited capacity to all users, and since last time I was bugged by people said it has to be mobile, so we actually got to build this special thing that's designed for the 12,008 so you can move it around. So now you see the fiber coming in here, it goes into the duct here because the duct came in after we put the first thing that happened was we put this thing on the fiber and it broke. SRP is good because it's actually protection switching, so fine. But next problem we run into is if you go too far away, like you will pull the fiber out of this rack. So if we actually do dial-up over the GSM here, using the aux port or the GSR, on the 7200 here, so you can actually have backup connectivity, but it goes from 4.8 gig to 9.6 kilobits. So it has a hard time even sending the BGP updates. Thank you. I see nothing.
Yeah. Thank you, Peter.